Looks like it's working. 6th grade, this is 4-10. This is on page 247. I've got a couple students that are absent today, and so you can pause the video and copy this stuff down. So what we're doing here is we're looking for relationships in data that you're getting. And the relationships, you can discover what they are sometimes in just a table or maybe even in a graph, and you can also see relationships in an equation. So I had students already copy this down. In this one, for example, we've got an equation of n equals m plus 4. And so they asked the question, how can you use the values in one row of data to describe the relationship shown in the equation, data table, and graph? And so if m is 1, then n is 5. M is 2, n is 6, and if m is 3, n is 7. And so what you would discover is that each value of n is 4 more than m. Now if you were to graph this, and the x value in coordinate pairs is always first, and you guys might want to copy that down because I've had 2 or 3 of you ask me about this multiple times. I'm just going to put parentheses x, comma, y. You should do the same thing. And whenever you see a coordinate pair, that's what that's called, it's referencing a point on a graph. And I think most of you know that by now. So if I was to, let's say, put a point right here, and you can see where I put it. Let me put a stick here. 6th grade. She's not here. Mr. Anderson, what is the coordinate pair or the coordinates of that point? Can you tell me?
1 and 8.
Yeah, 1 and 8. Sometimes you might be asked to even label the points on a graph, and so you would just do it that way. You would just put in parentheses their location. And so he knows the x value is first, so we go along the x-axis here, and we see that if we line it up with the dot, it's 1. And then we go along the y-axis, because that's the second coordinate, go along the y-axis, and it stops at 8. And so the coordinates are 1 and 8. So I graphed, actually they did in your book, and I drew a line. I graphed 1 and 5, and then 2 and 6, and then 3 and 7. And then I went all the way to 5, because at the bottom they ask us. They say draw a line through the points on the graph. So I've done that for you, and you guys can do the same thing. And I will say this, that whenever you draw lines on a graph, I always want you to use a straight edge. Don't try to do it by hand. It ends up looking sloppy. So always use a straight edge when you're drawing a line on a graph. And the pair, let me pull this back up, is 5 and 9. So 5 is the x value, and 9 is the y value, and that's where it would go. And then I just line through all those. And down at the bottom, when Maria has walked 5 blocks, Nancy has walked 9 blocks. That's what that ordered pair represents on the graph. All right, next page. Okay, example 1. So Booster Club is raising some money here, and they want to raise $50 to donate to a local charity. They buy pom-poms for 55 cents each. And it says how many pom-poms do they need to sell to reach their fundraising goal. So looks like it's $1 for each pom-pom, and they bought them for 55 cents. So for every one they sell, they're going to make 45 cents, which is what they tell us here. Then it says make a table to relate the number of pom-poms sold, which is N, to the amount of money they raised, which is R. Well, if they sell 10, that's just simply 10 times 0.45, because remember they're making 45 cents for each sale. That's going to be $4.50. If they sold 50 of them, then they would make $22.50. If they sold 110, they would make $49.50. Not quite the $50, but really close. Then they graphed it here for us at 50, and then at 110, which would be right about there. All right. So R right here, right next to the R equals 0.45 N. And earlier when I you guys copied down some of the things that I had written down, number 2, I told you to put a little star right there on page 250. That's what they're talking about. It says using the relationship in example 1, and example 1 is what we were just looking at. How many pom-poms must the Booster Club sell to raise $75? Remember the example they gave us, it was $50. Now they're asking how many do they have to sell to raise $75 for charity? Okay, so I do want you to answer the question. All right, look at the try it down below. All right, the Booster Club now raises 41 cents for each pom-pom, so that's different. We used to be 45, now it's 41 for each one they sell. Complete the table and graph and write and solve an equation to find how many pom-poms they need to sell to raise $50. So they're making a little bit less on each one. So write down R equals 0.41 N, because they're making 41 cents for each one sold. So if they sold 50, 50 times 0.41 is $22.50. If they sold 100 of them, it's going to be, and that makes sense, it's going to be $41, because when you multiply something by 100, you just move the decimal 2 places. And now the question is, how much R, and R is how much money they made if they sold 150. So I want you to answer that question. Now, the Y value here is how much money they made. The X value down here is how many they've sold. And so I drew a line, and there's 50, and it's really close to 20, just a little bit above 20. And then there was 100 at $41, so there's 100, and they made $41. Notice the dot is just above the 40 line. And then 150, which is going to be right here, so it's going to be somewhere along this line right there. I want you to put another dot that would go along there somewhere. All right? So make sure you do that also. Example 2 is relate an equation with 2 operations to a table and a graph. So right next to the N here, put hours, and next to the T, put temperature. That'll make it a little bit less confusing. And I'll let you look at that example on your own. But basically, they graph the ordered pairs on the coordinate plane, which is what they've done right here. So we look at 0 and 6. Here's 0. Remember, 0 is the first value. It's X, and Y is the second value. So I could put 0, 6 right there. That's what that point represents. Here's the next point. It's 210. So here's 2. We're doing the 2 first, and we're going up to 10. So 2, 10. All right. So I just wanted to make sure you guys understand the coordinate pairs, labeling these points, and what they're doing with the numbers in this chart. Then it says write an equation to describe the relationship. So t equals, they're starting with t, which is the y value. So t equals 6 plus 2n. Well, gosh, does that work? So T is the temperature, would be 10. So let's just look at this one right here. So T is 10, so 10 equals 6 plus 2 times n. What's n? N is 2, so that's 2 times 2. 2 times 2. 2 times 2 is what? 4. 6 plus 4 is 10 equals 10. So it works. All right? Now, down below in the diet, talked about this earlier. As a company makes decorations for pens, all the supplies cost $5, and the company plans to sell the decorations for $2 a piece. So each one they sell is $2 in their pockets. Analyze the relationship between the number of decorations sold and the profit by completing the table in the graph. Use the table in the graph to write and solve an equation to find the number of decorations that must be sold for the company to make a $15 profit. So I did the equation for you. So y equals 2x minus 5. The y is the dependent variable. X is independent. Okay? And all you have to do is plug in the values to figure out what y is. So in this first one, x is 3. So I'm going to look at my equation. Y equals 2x minus 5. Okay? So go back to my chart here. I don't know what y is, but I need to find out. But I know that x is 3. So I'm just going to plug in x in my equation. This is the equation that I gave you. So y equals 2 times what? 3 minus 5. What's 2 times 3? 6. What's 6 minus 5? Y equals 1. So I go back to my chart here. If x is 3, y is 1. That's all there is to it. All right? Now, go ahead and fill it out for different values, but you need to figure out, see how can I phrase this? When y is 15, because we're looking for a $15 profit, what would the x value be? Now, one way you could do it is, that might confuse you. I was going to say you could plug in 15 in place of y and kind of work backwards. But you could plug in some values for x and see what you get. How about if x is 5? What might you get? If x is 10, what might you get? But you're looking for a $15 profit, and when you have that, I want you to write the equation right there. All right? Okay, next page. All right, for those of you that are here, we already went over these. How can you analyze the relationship between dependent and independent variables using tables, graphs, and equations? And I wrote this down for you. You can make a table of at least three values. You can graph at least 3 ordered pairs. Or you can write an equation that represents the relationship between data given. Number 2, I already talked about that. Reference the first example. Instead of $50, they're asking you to raise $75. Number 3, we already talked about earlier. And so the answer is no, more bananas were sold than apples, and the equation is 4b divided by 2 equals a, or somebody might put a equals 4b divided by 2. All right, circle 4 and 5 rather. 6, I already gave you the answer to. Describe the relationship between the variables. They're referencing this table here. T is 1/4 value of D. Okay. So let's look at the very first box here, just to answer that. It says, complete the table, distance is D, T is time. And we're using this equation, D equals 4T. Well, they give us T. T is what? 1. D equals 4 times 1. What's 4 times 1? Okay. What if T was 2? D equals 4 times 2. What if it was 3? Yep. Okay. Then it says name 4 ordered pairs found on the line plotted using the equation. Plotted? I don't see where this is plotted anywhere. I don't see a graph in 4 through 6. Not sure what they're talking about there. But here's one ordered pair. 1, 4. Here's another ordered pair. 2, 8. Here's a third ordered pair. 3, 12. And you need to come up with a fourth one on your own. Yeah.
Wouldn't it be, so since it's D is 40, wouldn't it be 1 and 1, 2 and a half, and 3 and 3/4?
So D equals 4 times T. So I'm not quite sure what you're asking.
So if G is 4 times T, we can reverse that. So T is equal to 1/4. Yeah.
Right, which is what we answered number 6 with. The time T is 1/4 the value of D. 1 is 1/4 the value of D, and T, which is 2 in this case, is 1/4 the value of D, which is 8, and 3 is 1/4 the value of 12. All right, circle number 7, I want you to do that. 8 and 9. Put a little X and a Y. This is the X column, and this is the Y column. Same thing over here. This would be X, and this would be Y. Just that might make it a little less confusing. Circle 10, 11, and 12. For 11, it says, without using a table or graph, identify 3 other points on that graph, 3 other points that a graph of the equation in exercise 10 will pass through. Here's exercise 10. And so I gave you the x values for 3 other points. If x is -1, I want to know what y is. If x is 0, I want to know what y is. If x is 3, I want to know what y is. But they are talking about exercise 10, which is this one. All right, 12 is a stick. It's not graded. But if you want to try it, you can. 13, do that one. 14, write an equation to represent the amount of money refunded. R would be the amount of money that's refunded. And they're referencing this chart right here, movie prices. 15 is also not graded, and it's worth a stick if you want to tackle it. 16, part A, do that. Scratch out part B, not worried about that. So part A says write an equation that describes a relationship shown in the graph on the right. Okay. When you look at a graph like this, and you'll see more as time goes on, just want to make sure you guys understand, just because they don't label the points, don't be confused. If this is 2, the x-axis of 2, well, this would be what? 1. And this would be what? 3, 4. This would be 5. Same thing with the y-axis. If that's 2 and that's 4 and that's 6, well, this would be 1. This would be 3. And this would be 5. Okay? All right. That's it, you guys, in this video here.